So in count inversions is the problem. And given here that you are given an array, you have to count the overall inversion inside the array. Okay, so what do we mean by inversion? Let me just explain here, right? 2, 4, 1, 3, 5. This is your array. 2, 4, 1, 3, 5. This is your given array, right? So for any index element, okay, for any element that is at index I, right? Inversion corresponding to this particular element reside at index j such that j is greater than I, as well as array of I is greater than array of j. Got the point? So basically for 4 there are two inversions, 1 and 3. And then for 2 there is a single inversion, 1. You have to find out how many in total inversion are there inside the array. Got the point? For any element x, how many elements y reside towards its right such that y, all those elements y are smaller than x. This is what we mean by an inversion. Fine. So basically the formal definition of an inversion is corresponding to any index I, correct? All those elements at index j such that j is greater than I, but array of I is greater than array of j. This is the more formal definition. So how many in total inversions are there inside an array? That's what you have to count. Got the point, all of you? How to do it? Means what the question is meaning. Okay, can anyone try discussing what is the most basic solution you can think of the problem? Most basic solution.
The brute force approach.
Okay. Brute force approach. What that should be? 2, 4, 1, 3, 5. You set an I and towards. Then you run another loop utilizing the jth variable. Is jth element smaller than the ith element? No. Again, j goes one step ahead. Jth element is smaller than the ith element? Yes. So count plus plus. We increase the count by 1, right? Is the jth element smaller than the ith element? No. Jth element smaller than the ith element? Definitely no. So overall, for my current ith element, there is just a single element towards its right such that it is smaller than the ith element. Then you increase your ith pointer. Basically, you say, what about the next element that is residing at index 1? 2, 4, 1, 3, 5. Whenever my I will be pointing here, again start a loop utilizing the jth variable, point to all the elements that reside toward its right. Now is 4 small, how many corresponding j? My current ith element is greater than them. So for the next jth element and for the element that is residing 2 steps ahead, for all these 2 indices, the current ith element is greater than that. So count increases by 2 here. So finally the count will be coming out to be 3. Post that, the entire array is increasing. So you don't need to bother about that whether there is an inversions or not. For inversion to happen, right, what is the main requirement for us? Well, if my ith variable is pointing at an element x, all those elements that are being pointed by the jth variable, and what happens here? All these elements y, let me represent them as y, that are being pointed by the jth variable are smaller than the current element x. They all count for the inversion. Now for all such values of I, how many in total count of inversion I can get? That's what you have to find out. So if you wish to run 2 loops and try calculating, then what should be the time complexity? Can you tell me? Basically, I am having, basically I am setting I from 0 to n minus 2, right? And corresponding to any value of I am starting j from I plus 1 till n minus 1. That's it, right? That's it I am doing. So in total, I am running my loop for order of big O of n square time complexity, right? What are the constraints that has been given to us? What are the constraints that has been given to us? What can be the maximum length of the array? It is gonna be, the expected one is n log n, because your constraint of n is 5 into 10 to the power 5. If you go ahead and say it's gonna be an big O of n square solution, then overall it's gonna be 25 into 10 to the power 5. Sorry, 25 into 10 to the power 10, which is more than 10 to the power 8 allowed limit of unit operation. So that's not gonna work for us. You have to think in terms of n log n. Tell me, what are your thoughts? How can we just do it? What are your thoughts? Tell me that. What are your thoughts? How we can do it? How we can solve this problem? Take the question, read for 2-3 minutes, whatever comes to your mind. Let me know on that. Okay. Any particular thoughts? What are your thoughts on
Um,
the problem? Yes.
I'll go first.
Yeah.
So, since this is a sort of a merge sort based problem, I tried using the merge application where if you have like I and J uh, two pointers and whenever you go from let's say J keeps on increasing and I remains fixed, then if you break down the array, sorry, I'll get backtrack. 2, 4, 1, 3, 5. So when you have individual elements or divided 2, 4, 1, 3, 5, when you're trying to get that into a sorted array, how many times you are uh, making the change itself? Like let's say if my pointer is I is at 2 and say J is at 4. So no change is happening. So then we move sorry, pointer I is at 2 and pointer J is at 1. If you divide the uh, array into two parts, 2, 4 and 1, 3, 5, then I is at 2 and J is at 1. So then we see that J is smaller than I. So we take into what is the value of I and what's the value of J. So we get 2 and 1. And then we can sort this out like uh, 1, 2, like we do the merge thing in merge sort. And then if we go again to 4 and then we check other values, then we can get 4-1, 4-3. It's just I'm thinking of a modifying the merge part of merge sort.
Okay, let's see how
I,
does that happen. Okay, let's see that. So basically, if I wish to solve that utilizing merge sort, how merge sort comes into the play, we have to change the merge function a little bit. Okay, definitely there will be merge happening, but merge will be counting for us the inversion as well. Got the point? Merge, it will also merge, it will also count the inversion. Fine. Let's see. Suppose that I say 6, 5, 4, 3, 2, 1. This is my overall array. Let's fine. Now, how do merge sort happens here? Can anyone try telling me that? How do merge sort happens here? You divide it into two halves first. You divide it into two halves. And then I try sorting the individual halves. That is my first task that I do. Am I correct? I individually first sort the halves as per my merge sort algorithm. That's what I do. Then once I try merging them. How does that happen? I initiate a ith pointer on the left half that goes from start to the mid. And then I initiate a jth pointer from mid plus 1 to the end. That's what I do. Am I correct? Now tell me for one thing. Both the halves are sorted. Am I correct? All of you agree with me here? Both the halves are sorted. Now I say ith element is greater than the jth element. Getting the point? Ith element is greater than the jth element. Then can I say that fine, whatever is the value of I from I to mid, since the entire half is sorted, okay, from I to mid, whatever elements are there, they are all greater than the current jth element. Can I say that? If your ith element is greater than the jth element, since the entire left half is sorted, what I can say here that from I to the mid, all the elements will be greater than j. Can I say that? Okay, can I say, can't I say? Give me the answer here. All of you. Let us keep a count initially to 0. I say both the halves has been sorted successfully by merge sort. Now, once I am trying to do the merge, once I'm trying to implement the merge function, right now, either the ith or the jth element is to be merged for us. Either the ith element or the jth element will be merged in the final merged array, correct? That's how my merge sort works. So while performing the merge operation, I say the lefter half, this is the lefter half for us, right? So correspondingly, all the ith element will be having a smaller index as compared to the jth element. Currently, this is the case. Am I correct or not?
I don't think so. That would be the case.
Sorry?
I don't think that would be the case. Like if 6, 5, 4 and 3, 2, 1 are separated, then the right half would have some smaller values. Like if you mix up 6, 5, 4 and 3, 2, 1.
Couldn't get
Six,
you. Can you
three.
repeat that?
Yeah. So if we have 6, 3, 2, 5, 4, 1, am I audible?
Yeah. Tell me.
Yeah. So let's say the array is 6, 3, 2, and then 5, 4, 1.
Okay.
Then does this
Let's change
argument
that.
stand?
Let's change it. It's gonna be
Okay.
632.
5, 4, 1.
Okay, 541. Then
Yeah. And then we go into merge sort, the second step that you have
okay.
done.
Okay.
Then
How
we
much?
have
Okay, then we'll be having
2, 3, 6.
okay, so it's gonna be 236 after merge sort on the lefter half has happened and the righter half
Yes.
individually have been sorted by my merge sort. And it's gonna be, I
Correct.
guess, 145. Correct?
Right. Correct.
Okay, so my ith element. Once I'm trying to do the merge part, ith element is pointing to 2 and jth element is pointing to 1. That's what it is
Correct.
happening.
Right.
Okay, and my k is pointing to the first element of the merged array. That's what it is happening, right? Now, my
Right.
point is, if the ith element, right now, the lefter half, all the elements on the lefter half definitely have a lesser index as compared to the righter half elements. True on that?
True.
Right? So if I say right now, if the ith element is greater than the jth element, that means an element in the left side is having greater value as compared to an element on the righter side. since the entire lefter half is sorted, can I say from I to the mid index, whatever elements are there, they all will be greater than the current jth element?
Current jth element, yes. Yes.
Am I
I'm sorry
correct?
if
So
I misunderstood.
how many
Yeah,
inversion counts we are getting then? How
three,
many inversion counts we are getting?
three.
From I to the mid. From I to the mid, all elements are greater than the current jth element. So how many inversion counts we are going to get? Will it be equal to mid minus I plus 1? Tell me that. Mid minus I plus 1, this is the amount of inversions right now corresponding to this single jth element we are going to get. Correct? Okay. So what is the value of mid for us? Let us try. It's going to be 0 in this case. The mid is going to be at 2, I think. Okay. So it's going to be 3. If you try out this formula, it's going to be 2 minus 0 plus 1. So in total, 3 inversions we got, and add that to the overall count of my inversion. Correct? Okay, fine. And post that, since the inversion corresponding to the 1 has been calculated, whatever element could have been greater than 1 towards the left side, all have been taken into the count. Merge 1 into the kth position, take k to the next step, take j to the next step. Take j to the next step. Okay, which one is greater right now? Which one is greater right now? Ith element or the jth element? Tell me that. Which one is greater?
The J1.
The jth element is greater right now. So element towards the right is greater. So correspondingly, the ith element cannot form an inversion. Am I correct? Whatever ith element is, that is smaller. So I cannot take any conclusion that from I to mid, whether any inversion can be found with the jth element or not. True? Okay, since ith element is smaller, I am going to merge it to the kth position. Okay, move your I to the next step and k to the next step. That's how merging works. Okay, then what's going to happen? Tell me. Tell me what's going to happen then. Next, the ith element C, ith element is again smaller than the jth element. Ith element is again smaller than the jth element. Lefter side element is having smaller value as compared to the the righter side element. So again, I cannot take any conclusion whether from the ith position to the mid, how many elements are in total greater than the jth element. That's not a possibility based upon seeing just the ith element. Correct? So fine, I say merge your element 3 into the kth position, k one step ahead, and then I to the last element of the left side. Then what will happen? Tell me. 6 is again greater than the jth element. 6 is greater than the jth element. Can I say from my current ith position to the mid, whatever elements are there, they are all greater than the current jth element? For sure, since the left side is fully sorted. So if the ith element is greater, it's going to be fully more. Okay, from I to the entire last position of the lefter half, everything has to be greater than the current jth element. So since they are at just a single element, mid is also at 2, I is also at 2. So 2 minus 2 plus 1. Just a single inversion corresponding to the current jth element. I add it and I say fine. Merge into the kth position element 4, j will be one step ahead, and post that I remains as it is. Again, 6 is greater than j, right? From the jth element, 6 is greater than that. So again, an inversion we are getting from I to the mid. How many elements? 2 minus 2 plus 1. It's going to be 1 again. So add this one into the count, that another inversion I got. Fine. And then post that, fine. Again, jth element is going to get copied into the kth position, k one step ahead, and j exhaust. J exhaust the entire righter half. Correct? Whatever element you are having into the ith position, just copy that as it is into the merged array. That's it. So what we got, while I was merging the lefter half and the righter half, 5 inversions I got in total. That if you compare the lefter and the righter half, in total 5 inversions you are going to get. All good, but is it the total amount of inversion? Tell me that. Is it the total amount of inversion? Tell me that. Is it the total amount of inversion? Some inversions we have left, right? We never compared 4 with 1. We never compared 5 with 1. Okay. We just compared 6 with 5, 4, 1. 3 with 5, 4, 1. 2 with 5, 4, 1. These are these considerations. Whatever are the elements we are having into the lefter and the righter half. If you just compare them, then the number of inversion we are getting is 5. 6 is greater than all the elements, so 3 inversions. 3 is greater than, this is 1, I guess, right? 3 is greater than 1, so 1 inversion corresponding to that. 2 is greater than 1. So 1 inversion corresponding to that. That's in total 5 inversions. While comparing the lefter and righter half, that's what we got. But in total, we never see that. See, some more inversions are possible. What are that? 6 is both greater than 3. 6 is both greater than 2. 5 is both again greater than 4. 5 is greater than 1. 4 is greater than 1. These are the inversions, as well as 3 is greater than 2. These inversions we never got. So my point is how to account for that. How to form the relation. We know that while merging, we are gonna compare lefter and the righter half. We definitely are gonna get some of the inversions from in between the elements of lefter and the righter half. But in total, what should be the relation? If you wish to count the inversion of the entire array, how that's gonna be? What are your thoughts? So can I try bringing up the relation that if I am right now calculating the inversion in between start to the end, that is roughly equal to the inversion from start to the mid. In between start to the mid, how many inversions are possible? Correct? Plus the number of inversion from mid plus 1 to the end. Correct? And again afterwards, while merging the lefter and the righter half, how many inversions I got? In total, if I add all these three, okay, you wish to merge start to the mid and mid plus 1 to end. While merging, whatever inversions have got returned. Along with that, I have to take into the account how many individual inversions are there into the lefter half, how many individual inversions are there into the righter half. Once these relations are ready, once you add up all of them, it is gonna be fetching me the number of inversions in between start to the end. Got the point? Got the point? Tell me that. Got the point? How to actually go ahead and once you have sorted the individual halves, how you have to actually go calculate the inversion by taking into the account while comparing the lefter and the righter half elements. But individually, these halves are going to have their own inversions that we are not taking into the account. Correct? So while sorting these halves, right? While sorting these halves, we have to first say, fine, bring on while I'm performing the merge sort. While I'm performing the merge sort, this merge sort is not going to sort your entire array. It's going to bring as well how many inversion individually the halves are having. And post that once their inversions are ready, they have been individually sorted. Then try calculating individual lefter half and righter half. If I try merging them, what is the overall inversion we are getting? Adding these three entities, we are gonna get what is the in total inversion in between to the start and end index we are gonna have. Correct? Tell me. Is it good?
Is the first inversion not going to be done by itself?
As
Like,
in?
the first two inversions, like, as in, say there is 632 and then it gets sorted into 236,
So
right? So
in this particular, no, actually this is the comparison between the lefter half and the righter half elements. While you have broken it up, let's suppose you are trying to sort, you say that sort the elements in between 632. So again, you further break it into two halves in between 6, 3 and 2, right? In between 6, 3 and 2. And once you try merging them, then how many inversions are there in between these 3, 6, 6, 3 and 2? Then while merging these two halves, you're gonna get the inversions of these three elements. Further, it's gonna be 6 and 3. That's gonna get broken up further. Let me write it somewhere else. Let us see how it works. So I say 6, 3, 2. Sort this off. So and what's gonna happen is that it's gonna broke up further. We are gonna say sort 6, 3, and then post that I'm gonna say sort 6. So 6 is already sorted. It's gonna return. Sort 3, 3 is already sorted. It's gonna return. Try merging 6 and 3. Try merging 6 and 3. Then what's gonna happen here? Once you try merging, the ith element points to 6, the jth element points to 3. Once you try merging, then what happens is that the ith element is greater than the jth element. From I to the mid, just there is a single element. So overall, I say while trying to merge 6 and 3, I am getting a single inversion, right? They will be getting merged. Finally, your array status is gonna change 3 to 6. It's gonna be, and it's gonna after merge operation on individual halves and merging of 3, 6 are done. It's gonna return to the original from wherever it has been called. And right now, since the merged array contents, that is 3, 6 have been copied to the original array. Your original array is going to look like 3, 6 and 2 is going to be into the right half, right? Okay, now you say 3, 6 have been sorted and corresponding to this half, there was a single inversion. We have counted on that, correct? You say go on and sort 2. 2 is single element. It's going to return. Then 3, 6 and 2. That is going to be merged. That is going to be entirely merged for you, correct? So once you try merging of these three elements, what we are getting, ith element is here, jth element is here. Ith element is greater than the jth element. So add 2 to the count. That's fine. One inversion was in between 3, 6. Then we are getting two more inversion. 3, 6 both are greater than 2. That's for sure, right? Okay, then you merge 2, I guess, from here, and rest all the elements will be going as it is to the leftover merged array slots, whatever we are having. So in total, what we are able to see, in this particular range of elements, there are 3 inversions that we have counted. Okay, how did we count it? I said if I wish to count the number of inversion in between 6, 3, 2, I have to first say if I try on to merge sort 6, 3, correct? Individually, then while merge sorting this, how many individual inversion count I got? So I got one individual inversion count while merge sorting this, right? Then I say if you wish to sort a single element, how many inversion count is you are gonna get of this if you are taking the range from index 2 till index 2. So that is having a single element, no inversions are possible. It's gonna give you 0 inversions. Now try merging these two individually. What you are gonna get? You are gonna say, fine, if I tried merging them individually, 2 more inversions I got. 3, 6, both are greater than 2, correct? So I say, fine, 2 more individual inversions I got, and after merging, my array is looking like 2, 3, and 6. This happened for us, right? So overall, if I say, in order to merge sort 6, 3, 2 entire range of elements, how many inversions I got? While merge sorting the lefter half, how many inversions? While merge sorting the righter half, how many inversions? While merging both the halves, in order to sort the entire array, how many inversions? 2. So you have to add all these entities, correct? You have to add all these entities, and then overall 3 inversions corresponding to the range of elements 6, 3, 2 of the lefter half. That's what I'm gonna get. Correct? Got the point? So how to break the problem? How to break the problem? In order to count the inversion count, in order to get the inversion count from start to the end, you have to first individually see what is the number of inversion in between start to mid. Then you have to see how many inversion in between mid plus 1 to end. And then once their individual C1 and C2 are ready and has been returned by your merge sort, right? Try merging these two halves. Some C3 count of, again, inversions are you're gonna get. Add all these 3. Add all the 3 entities that corresponding to the lefter half, these are the inversion count. Corresponding to the righter half, these are the inversion count. Corresponding to merging all the array elements and forming the overall array, I am gonna get C3 number of inversion count. So in total, how many inversion count I got? C1 plus C2 plus 3, C3, while sorting all the elements in between start to the end. And that's what I need to return at the end. Fine. Tell me that. Is it clear? Tell me that. Is it clear? The coding is quite straightforward. I think all of you have the merge sort code. Is it that? The coding is quite straightforward here, and let us see here. Just let me open it up. CPP codes. There is nothing that much that we are required to do. Sort, where is merge sort, by the way? Merge sort. Okay, see here. What we are required to do. Okay, while merging. Correct. So right now I have to change the return types of merge and quick merge sort. It's gonna be, I guess, integer for us, that okay, some integer amount of inversion my merge sort is gonna return, right? That's what we are required to do. And I am gonna just say int inversion. And this is equal to that of your overall, how much merge sort is returning as inversion count if I wish to sort and all their elements in between 0 to n minus 1. Correct? And at the end, no need to, you can print all the array elements. Inversion you can print at the end, right? That's what you can do. Fine. And while merge sort, what I require to do is that if suppose there are no array elements or there are just a single array element into my what I wish to merge sort, right? what I require to do here is that I have to return 0. That corresponding to these two cases, no inversions are possible. Return 0 in such cases. What else I require to do? Tell me. Now there will be C1 amount of inversion count once you are trying to merge sort the elements in between start to the mid. Again, they are gonna be C2 amount of inversions inside the right half from mid plus 1 to end. And there will be C3 amount of inversion count while you are trying to merge the left and the right half elements. At the end, I am going to say return the overall inversion C1 plus C2 plus C3. That's it. That's it. Correct. And right now, okay, fine. So I have to do for one thing. Inside the merge, I have to change the definition a little bit. I have to say that it's an integer merge because it too returns some amount of inversion, right? Okay, so let me keep a count here. How many inversion in between the elements of left and the right halves are possible? So basically, if your array of I is lesser than equal to array of j, that till that, so there is no inversion corresponding to this. But what about array of I is greater than array of j? Then we are getting some inversion into the else case, right? What is the inversion? You have to just increase into the count that my count will be going up by mid minus I plus 1. That's it. Done. Into the overall merge sort, just try manipulating the merge function. That once my ith element is greater than the jth element, all the elements from I to the end, mid, right, will be definitely greater than the jth element. So these amount of inversions are possible. That's it. Okay, whatever is the last merge, whatever is the last count, whatever we got in terms of while merging them, that's I'm going to return from the merge function. That's it. Let me just try copying it from here. Let me just try pasting it here, right? And suppose that we can just try having a look that how my overall functions are looking like. Okay, so I think I have taken this particular array as well here, and let me try running it. Okay, 549261. Let's see how it overall, how many inversions we are getting. Yeah, aren't we printing that separately? Printing the number of inversions. Okay, I'm sorry for here. Let us print another line so that we go to the next line and print the inversions. So inversions are, in total inversions are 10 here. Are we correct? Let's check that. In total inversions are 10 here. Okay, let's see how whether we are correct here or not. So basically, how many inversions are possible inside this array? It is gonna be 6 and 1. First pair 6 and 1, right? This is an inversion. Suppose that there is 2, 1. This is an inversion. 9, 2, 9, 6, 9, 1. 3 more inversions. Anything else? We can get 4, 2 and 4, 1. This is an inversion. What else we can get? 5, 4 is an inversion. 5, 2 is an inversion. 5, 1 is an inversion. In total, 10 are coming. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct? So overall 10 inversions, we are getting it correctly. There is no problem at all. Correct? You can try out with several other examples as well, such that, let's say, let me take a completely sorted array 1, 2, 3, 4, 5, and 6. Correct? So there are 0 inversions in such cases. No problem at all. Fine. Even if all the elements are same, it's going to give you 0 inversion. So while you are merging two halves, you have to just keep change into one scenario. If suppose your array of j is array of I is greater than array of j, jth element is going to get merged. But while the time, I'm going to try counting how many inversions we have seen so far. So from ith to the mid element, all the elements are basically having inversion corresponding to the jth element. So how many count to be increased? Mid minus I plus 1. That's it. Okay, then overall, how to break the subproblem? If you wish to count the number of inversions from start to the end, you have to say, fine, if start is greater than equal to end, either there are no elements here, either there are 0 elements. So return 0. Sorry, either there are 0 elements or 1 element here. You return 0 from here. Or else, if there are more than 1 element, into the lefter half, there can be some inversion. Into the righter half, individually, there can be some inversion. So merge sort is going to return that. At the end, I say while merging from start to mid to the end, do one thing. How many inversions are possible? Return that and store that into C3. Once the entire from start to the mid, everything has been sorted fully. Whatever is the overall inversions you got in the range of start to end, return all of them. That's it. That's what you are required to do. Tell me, is it fine? No complexity changes again because we are just performing merge sort. You are just performing merge sort, so it's gonna be n log n. Just I am doing one thing while performing the merge sort. I am keeping a track of count. How many inversions are possible? Nothing else I am doing. Fine. Clear to everyone? Tell me that. How to count inversion? Is it clear to everyone or not? How to count inversion? In total inversion inside an array. Tell me that. Is it clear? Is it clear? Whoever requires, take the code. I think, sorry. I think, but the indivisible function is enough. Given this and the merge function as well. Is it clear to everyone? Please tell me. If you wish me to repeat something, I'm going to repeat. Tell me that. If you wish me to repeat something, I'm going to repeat that. इन्वर्शन काउंट कॉन्सेप्ट सबको क्लियर हुआ? वो बोलो. आप खुद कर पाओगे? आप लोग बोथ मर्ज सॉर्ट एंड इन्वर्शन काउंट आप लोग खुद कर पाओगे? खुद कर पाओगे? बोलो. How many of you can do? How many of you can't do? This is the straightforward question. What you can do from merge sort, right? बहुत इंटरव्यूज वगैरह में बहुत पूछ सकता है कोई भी. ठीक है, ये बहुत नॉर्मल क्वेश्चन है जो पूछा जाएगा. There is yet another way of solving this utilizing binary index tree or Fenwick trees. You have to go to the concept of range updates in order to do it. ठीक है, we can see that at the end of our data structure algorithms. More better way, I think, Fenwick trees. Okay, and fine. So can we jump onto the concept of quicksort? How to perform quicksort? Tell me that. Or should I keep it till here today and tomorrow we can take the quicksort topic? What is your preference? Tomorrow let's start in at 9:30 sharp. 9 p.m. आप लोग आ पाओगे? 9 p.m. or 9:30? What should I do? Okay, I'll let you know. Afternoon कल नहीं हो पाएगा. ठीक है, मैं नहीं रहूंगा. So it can be either 9 or 9:30 p.m. Something around that time we can do it. Okay, let's do it at 9:30 only. And tomorrow I'm gonna discuss quicksort. आप लोग नेक्स्ट वीक एक्स्ट्रा क्लासेस के लिए तो नहीं रह पाओगे ना, जैसा बोल रहे थे. When can we actually cover up the Puja holiday classes? That's what I wish to ask.